I'm using Spider because it's better for graphs than Jupyter Notebook. If I didn't explain that already. All right. So for the imports, matplotlib, as you know, that is the king of graphs in Python. The math module, you'll see how we use it later on. YFinance for the data, numeric NumPy right here, and PyPlot to showcase the graph. There is no pandas in this one. I'm missing it. I know you're missing it, but unfortunately, we don't need it for this project. All right. Next, we have our windows, which is a list of days. So it's gonna be 30 days, 60 days, 90 days, and 120 days. And the significance of those is 30 days is 1 month, 60 days is 2 months, 90 days is 3 months, and 120 days is 4 months. Quantiles is 25% and 75%. So we're going to need the lowest 25%, which I'll explain down here, and the highest 75%, again, I'll explain down here. And from there, we just have some empty lists for values that we're going to fill in with our data. So the minimum, the maximum, medium, the top quantile, which is going to be the 75 percentile, the bottom quantile, which is the lowest 25 percentile, and the realize, which is the actual values, which we're going to explain right here when we get into that function. All right. As always, we got to download the data. I'm using GameStop, as you can see here. The start value is the beginning of this year, and the end value is the last date as to this recording is the last date, which is yesterday. So I'm downloading the data for GameStop there and saving it in a variable called data. Now we got to find the realized volatility, which is the actual volatility. This volatility has already been shown. We don't have to forecast it. It's already been created, right? And from there, we have to have the price data, which I'm going to show you how we're going to pull that up later on. And the window, we're going to use the 30-day window, which is 1 month. Now, the log returns is the compounding returns. It's not just the regular returns. And we do that by getting the close prices of the price data, and then shifting it and applying a function that's already pre-built with the NumPy package called np.log. And from there, we're going to use the rolling function, the rolling module, sorry, that takes into account all of the windows, not just one window. It gets the standard deviation of that, and it squares it by 2, which is every day within a trading period. So as you know, there's 252 trading days within a year. So that's why we're squaring it by 252. Now the rolling module, you're going to see a lot if you ever get into coding simple moving averages or exponential moving averages. Windows and rolling kind of always go together. That's how you get the 20-day moving average, the 60-day, et cetera, et cetera. Watch my other videos on TikTok and my Instagram page to see how I actually use I use this function with simple moving averages and exponential moving averages, right? So that's what we're going to return there to get the realized volatility. Now, for window and windows, so again, this is just going to be getting all of these values within this list. So for each one, so for each window in window, the 30-day, the 60-day, the 90-day, and the 120-day from windows, it's going to be each individual one. What we're going to do here is get the realized volatility. So we're calling this function here, and we're going to put the window for each one of those values. So it's going to be a 30-day window, 60-day window, 90-day window, 120-day window. And we're making the price data, which again, I explained right here, we're going to explain later, which is going to be equal to the data, which is Yahoo Finance's data variable that we declared here. And from there, we're going to append these empty lists. We're going to get the minimum realized volatility, which is going to be equal to the realized volatility. I know you use an estimator, and we're going to get the minimum value for that. Same thing with the maximum value. We're just going to get the maximum value inside the realized volatility. Median value, again, the median value. So these are all modules within that you can work with when it comes to these lists. And then this is where we're going to get the quantile, which is the percentiles. So this is where we're going to get the lowest 25 percentile, which is the bottom quantile. As you can see, it is indexed at 0. 0 is the first value within the list with the bottom 25. And the top one is at quantile 1, which is indexed at 1, which is, again, it's 0, 1. In programming, we don't do 1, 2, we do 0, 1, 2, 3. So the index value for that is 1, which is, again, 0.75, which is the top 75 percentile. And we're going to get the realized volatility, which we're going to just state there. And from there, we're now just going to be plotting these values. All right. Now, this simple plot function. So plt.plot the windows. So again, this is one of the windows: 30 day, 60 day, 90 day, as I stated here. And from there, we're going to label each one. So the min, again, we appended the realized volatility for the minimum value of that for the min. And then we're going to actually use that data here to plot the minimum value. Same thing with the max, median, bottom quantile, and of course the realized volatility. Now, I want you to also pay attention to this F string. I know you're probably wondering, like, these are simple: min, max, medium. Why are we using this syntax here? This is considered an F string. This is when you want to substitute a value within a string. Because I might actually go up here and change it from 0.25, meaning the lowest 25 percentile, to like 0.10. I don't want to have to like change this to 0.10 and then come back down here and change it to 25 to 10% percentile. So I want it to automatically update once I feel changing any one of these quantiles here. So I can just use an F string as opposed to having to change up there and then come back down and changing here too. This makes it a lot easier. All right. From there, we have the X ticks, which is just going to be the X label values, which is going to be the windows. So it's going to be 30 day, 60 day, 90 day, and 120. Don't worry, when I show up the graph, you're going to see it. And the legend is just going to explain the labels for each one so you know which one you're looking at. All right. So that's generally how all of this works. Now let me show you the graph. Let me run this now. As you can see, let me expand this a little bit so you can see better. And let me tight layout so you can actually see it better too. All right. So as you can see, the legend explains each value. The min value is for the minimum realized volatility. It's at the bottom. Of course, it's the smallest amount. The max is at the top. It's the highest amount. The medium is at the middle, of course. And then we got the lowest 25 percentile, which is a little bit above the minimum volatility. And we got the highest 75 percentile right below the highest, the maximum value. And the realized is actually the dotted line here, this red dotted line here. And from there, you can actually use your eyes to kind of dictate how the realized volatility matches up against all these other values. As you can see, it's kind of following the minimum value. It's actually even smaller than the actual 25, the lowest 25 percentile. So this lets you know that volatility is very, very low for this stock, which is GameStop. And letting you know that this is actually a very, very cheap options contract. Because volatility is so low, it's going to be extremely, extremely cheap. Now, let's go back. Let's change this to something like Apple. Let's run this. All right. Opposite. It's actually at the maximum value. Like, it's even higher than the actual 75 percentile, but you've seen it actually reverted down to the 75 percentile and even close to the medium. So this one is kind of reverting back to medium, which is mean reversion keyword, which you're going to learn how to create a stock trading bot in AlgoWorld based on the mean reversion strategy. So we're going to talk about that later. But as you can see, this one means that Apple's contracts are pretty much very expensive and very volatile, as you can tell, because it's at the highest amount. So pay note to that. So that's essentially how the script works. From that graph, you can kind of come away with those conclusions and letting you know how to place your trades. I'm going to be using this for placing my trades in the going future. That's why this script is so important. Sorry, stay in call. But yeah, that's generally how it works. And if you want to actually get the code for this, I'm going to have this in AlgoWorld. Speaking of AlgoWorld, we are having a Black Friday sale. So if you want to get half off for 1 month, click the link below and sign up. You'll get the script for this. You'll get my options trading scripts. You get every script that I'm writing in real time, as well as the signals for my bots. So that means that not only will you be learning how to write these scripts, but you'll be able to make money immediately, even if you don't have the scripts up. So that way you learn and make money at the same time. Why not? The best of both worlds. So sign up link in the bio and stay tuned for the second project, which I'm going to try to peek of now, how to schedule a Python script, because we're going to be building a database. stock database that's automated. Stay tuned for that, and I'll see you guys in that video. Peace.